Dear viewers, Assalamu alaikum. Today we will discuss that how we can convert IC50 values to Ki values. That is how we can calculate the inhibition constant by using IC50 values. Before this, we made videos on Ki values, that how we can calculate inhibition constant value by using kinetic studies, and there we used GraphPad prism, and during in vitro enzyme inhibition reaction we use different concentration of inhibitors and substrates, and then we calculated the Michaelis equation and then double reciprocal plot, and after that we made a graph, and then we find out that how we can calculate the inhibition constant value for different type of enzyme inhibition mechanisms, like it is competitive, uncompetitive or non-competitive. Today we are not going to discuss that kinetic studies, but we will discuss that how we can directly convert IC50 to Ki values, and we can use Cheng-Prusoff equation, or we can also convert IC50 to Ki value by using different online tools. So these are the important this is the important step, that how we can convert our IC50 value to Ki value, because most of the time student ask that if we don't want to go kinetic studies, or how we can convert IC50 to Ki value. So during enzyme inhibition reaction, when we perform in the lab, so the first step will be how to find out the percentage inhibition of our inhibitor. So we will use this formula, that it is the percentage inhibition. So percentage inhibition is equal to OD, optical density of the control, which is without inhibitor, or it can be absorbance of the control minus absorbance or OD of the inhibitor divided by OD of the control into 100. So in this way we can find out that the concentration that we use during our enzymatic reaction, so what will be the percentage inhibition. So after this we will find out the percentage inhibition at different concentrations of inhibitor. Let's suppose 4 or 5 different serial dilutions. We will make serial dilutions of our enzyme inhibitor concentration, and then we will calculate the percentage inhibition with all these concentrations. Let's suppose, or we have an example that at our first enzyme inhibitor concentration we get 94% inhibition, then we will go to serial dilutions up to the concentration that gives below 50% inhibition. So it should be below 50% inhibition. That's so that we can find out that the at what concentration we will get 50% inhibition. So in this way we can also we will go to 0% up to 0, because there is no concentration of the inhibitor, which is our control, and at control the enzyme activity will be 100%, and then we can minus 100. So percentage inhibition minus 100, we will get these percentage activity of our free enzyme. So in this way then we can find out the IC50 values. I have made a video 4 to 5 or 6 months before that, how we can calculate IC50 values by using GraphPad prism, and that is the direct method that we use nonlinear regression analysis, and we can find out the IC50 value. But here I am going to also show you that we can find out the IC50 value by curve fitting method, or we can also use Microsoft Excel, and we can connect all these data or points, and then we can make a graph which is also a nonlinear graph, and then we can find out that at 50% inhibition what concentration of inhibitor will be used. So we can find out the percentage inhibition of our inhibitor. Here is an example of carbonic anhydrase activity, which is going to increase, and here the concentration is going to increase. The concentration is going to increase, and then we get percentage activity. So in this way, here we have IC50 value of, let's suppose, 2.79 exponent 10 power minus 9 molar. Then we should know that what is the difference between IC50 and Ki value, because most of the time students get confused that what is IC50 and what is Ki. So both of these are different, because Ki is the inhibition constant and it is the equilibrium constant for the dissociation of enzyme inhibitor complex. So we can say that it is the dissociation constant of enzyme inhibitor complex, and I am going to detail in our next slides that how we can determine what is the Ki in more detail. And IC50 is actually the concentration of the inhibitor that gives 50% inhibition, that gives half the reaction rate of enzyme catalyzed reaction, that reduces the rate of reaction to half. So it is the concentration of, actually it is the concentration of inhibitor that reduces the rate of reaction into 50%, or simply we can say that the concentration that gives 50% inhibition. Now, what is Ki for competitive inhibition? And keep in mind that Ki will be different for each different type of enzyme inhibition, and it will also be different in we discussed in our previous videos that there are two type of enzyme inhibitors, reversible and irreversible. So after this slides, we are going to discuss reversible type of enzyme inhibitors which are not tightly bound. And after this video, we will make another video in which I will discuss that how we can find out the inhibition constant for tightly bound inhibitors. But here we are going to discuss the loosely bound or reversible type of enzyme inhibitors. And in this reversible type, we are going to discuss now competitive inhibition. So if you look at the normal reaction of enzyme substrate complex, it is on the left side, it is the normal reaction in which the first step is reversible, and the here K1 is the forward rate of reaction, equilibrium constant for forward reaction, and K minus 1 is the equilibrium constant for backward reaction. And what is the dissociation constant Kd? It is the ratio of rate of reaction of the backward divided by rate of reaction of the forward. So it is the dissociation constant. And then we get product, which is also the constant is K catalysis. If we have an inhibitor, so in competitive type of enzyme inhibition, the inhibitor competes with the substrate and it does not allow substrate to bind, then reaction will proceed in this direction. An inhibitor will bind to the active site of the enzyme, and then again we will get enzyme inhibitor complex. And in this case, the constant for forward is Ki and constant for backward is K minus I. And again, here is the Ki, which is the actually the inhibition constant, which is capital K. I have written here that it is the capital Ki. Here is the small Ki, which gives the, so it is again the ratio of the K minus I divided by Ki, or it is the again the ratio of the equilibrium constant for backward and forward reaction. So here is our inhibition constant Ki, which is in capital K and subscript I. So it represents the Ki for competitive type of enzyme inhibition. Now I am going to show you that how we can convert IC50 to Ki value by using Cheng-Prusoff equation. So here is the Cheng-Prusoff equation, which represents that Ki is equal to IC50. So we should know the IC50 value before this, and the substrate concentration and the Michaelis constant Km value. So we should have these values, that is IC50 concentration that we used and Km plus 1. Then we can calculate the Ki value. And if the substrate concentration is equal to Michaelis constant, which is also the substrate concentration, but it is the half of the Vmax. So at this, if this condition occurs, that inhibition constant Ki will be the half of the IC50. If we have the IC50, let's suppose 50 micromolar, then the inhibition constant will be 25 micromolar. If the substrate is very greater than the Km value, then Ki will be very less than IC50 value. And if the substrate concentration is very less than Km, then the Ki value will almost equal to the IC50 value. Here I have given an example of carbonic anhydrase in which we have the substrate concentration. So here we have the substrate concentration of an enzyme, which is the carbonic anhydrase, and it is 17 millimolar, and the Km value for human carbonic anhydrase 1 is 4 millimolar, and for 2 the Km value is 9.3 millimolar. So we can find these type of values for our enzyme by literature also, and we can also calculate. So, and the type of enzyme inhibition can also be calculated by, I have discussed in our previous study that we can use GraphPad, prism, and the double reciprocal plot or Dixon plot. Ki for uncompetitive type of enzyme inhibition. During uncompetitive type of enzyme inhibition, the inhibitor will bind with the already enzyme substrate complex. So in this case, there will be the already enzyme substrate complex, and then inhibitor will go to bind either to the allosteric side or outside the enzyme substrate complex, and then it will make a ESI, that is enzyme substrate inhibitor complex. So in this case, that again the inhibition constant will be the K minus I divided by Ki. So in this way the Ki value will be due to the ratio of these two values, but here the substrate is must, because before substrate it will not go to bind to the inhibitor, and it is the uncompetitive type of enzyme inhibition. For finding the IC50 value for uncompetitive type of enzyme inhibition, we will use Cheng-Prusoff equation of this type, that is IC50 value, and here we will use Km divided by S plus 1. Before this, we know that for competitive we use this S divided by Km plus 1, but here we will use Km divided by S plus 1, and these are the conditions. If substrate is equal to the Km, again the Ki value will be the half of the IC50 value, and here it is opposite, that if the substrate concentration is very greater than the Km, then Ki value will be the IC50 value, and if the substrate concentration is very low, then Ki will be the very low than IC50 value, because the substrate concentration does matter in this type of enzyme inhibition. Ki for non-competitive enzyme of inhibition. This is the non-competitive type of enzyme inhibition reaction. Here is the actual reaction of the enzyme substrate complex. So in case of non-competitive, inhibitor can bind either directly to the enzyme, but it will not compete with the substrate. Either it will bind with the enzyme and it will give us enzyme inhibitor and substrate. So in this case, the inhibition will be the Kia. It is the rate equilibrium constant for forward, and K minus Ia is the backward. So A represents that it is our first condition, and in second condition, inhibitor can bind with the enzyme substrate complex, and it will make ESI complex like uncompetitive type, and in this case the inhibition constant will be the B. So here we are going to use B. So when we take the inhibition constant Ki, so we will call it Kia for first type and Kib for second, but in case of non-competitive inhibition, Kia will equal to Kib. So we can calculate this Ki or this Ki, so both will be the equal. So it doesn't matter that what kind of Ki we are going to calculate, but we will use IC50 value, so it doesn't matter. And for converting IC50 to Ki value for non-competitive type of enzyme inhibition, it is very interesting that the Ki value will equal to IC50 value. So we are not going to use that Cheng-Prusoff equation, and in case of non-competitive, the Ki value will be equal to the IC50 value. But when S is equal to Km, when the substrate concentration is equal to Km, our substrate is very greater than our substrate. So all these conditions represents that Ki will be equal to the IC50 value in non-competitive type of enzyme inhibition. Ki for mixed inhibition. For mixed inhibition, it is the same as in case of non-competitive. So most of the time it is confused with the non-competitive type of enzyme inhibition. But in this case, Ki will not be equal to the Kib. So inhibition constant for A will not be equal to the inhibition constant for B, and I have shown in my previous videos that what is the mixed type of enzyme inhibition and how it is represented by the double reciprocal plot, and I will also make a video that how we can find out the Ki value by using GraphPad prism. Now this is the important step, that how we can convert IC50 to Ki value by using different tools or software. So here I am going to represent a link or a software that can convert IC50 to Ki value, which is called IC50 to Ki converter, which is online tool, and you can use this tool. This link is provided here, so you can use this tool to calculate the IC50 value. So I am going to show you that here. So here is our this link, so BatDB. So we can use this tool, which is IC50 to Ki converter in enzyme substrate inhibitor system, and here is the reference for this. So okay, now go to this one, enzyme concentration. So here we will put our data, that what is the enzyme concentration. Let's suppose it is 0.006 micromolar. So here it is shown that we will use the micromolar units, and the substrate concentration is, let's suppose, 30 micromolar, and Michaelis constant is, let's suppose 13 micromolar, and the IC50. So here we will use the inhibitor concentration that gives 50% inhibition. Let's suppose here it is the IC50 is 3 micromolar. Now we will go to calculate. So here, okay, so calculate. Now it calculates Ki value for all type of enzyme inhibition. This is also a very good for us, that it will give us the if we have the competitive inhibition, it will be 0.906 micromolar Ki value. In case of uncompetitive, it is 2.09. For non-competitive, it is 2.99. It is the classic or reversible type, and these are the parameters that we provided. And the mode of inhibition for tightly bound, it also provides us tightly bound Ki value for tightly bound inhibitors, that is for competitive, for uncompetitive, and for non-competitive. So here we can observe that for non-competitive the Ki value is 2.99, but in case of non-competitive in tightly bound it is 3.00. So we can these calculations are based on the same formula that I have shown you in my presentation. So in this way we can directly calculate without using formula. We can only put our values, and then we can find out the Ki value for different type of enzyme inhibition. So we can use this tool, and there are some other tools we can find out from on the server that we can use. So thanks for watching my video. In our next video we will come with some other topic which will be interesting for you. So thanks.